Good afternoon to all. In this class, we discuss the shape selective catalysis. Okay, shape selective catalysis. Shape selective catalysis. What is mean by shape selective catalysis? The shape selective catalysis is nothing but the catalytic reaction that depends upon the porous structure of the catalyst. Okay, the catalytic reaction, okay, that depends on the size, on the porous structure of the porous structure of the catalyst, and the size of the reactant and product molecule is called as shape selective catalysis. Okay, means what? The catalytic reaction, the catalytic reaction, the catalytic reaction, okay, that depends that depends upon the pore structure. Means pore means small holes. Okay, the pore structure, the pore structure of catalyst. You already know the meaning of catalyst. And the size of the reactant and the size of the reactant and product molecules is called shape selective catalysis. Is called shape selective catalysis. Means the catalytic reaction in which that depends on the pore structure of the catalyst as well as the size of the reactant and product molecules are called as shape selective catalysis. If they ask for example for definition, you write this definition, and if they ask, write the examples. Example for this one as zeolites. Zeolites are used. Zeolites are microporous aluminosilicates. Okay, silicates, and hence they are good shape selective catalysts because they are having microporous structures. Zeolites are having small microporous aluminosilicates. So and hence they are used, and hence they are good shape selective catalyst. Shape selective catalyst. Okay, because they are having pores, microporous aluminosilicates. Because they have pores, because of this reason they are good to select shape selective catalyst. Okay, and the next thing is almost the reactions taking place in zeolites. Okay, the reactions which are taking place in zeolites, okay, depends on the size and shape of the reactant and product molecules as well. So not only this microporous aluminum silicates means that that they also depends on the reactions also depends on what the size and shape of reactant as well as product molecules. So okay, and on the pore and cavities of the zeolites, okay, as well as pores and cavities of the zeolites, as well as size and shape of the product molecules or reactant molecules. Okay, example. Okay, example for this one is example example ZSM5. ZSM is nothing but zeolite secondary mobile 5. Its name ZSM5 is used conversion of alcohols to petrol. You can write as gasoline. Okay, you can in bracket write as gasoline. So in this case ZSM5 means zeolite secondary mobile 5. It is used for the conversion of alcohols to petrol. Okay, what is mean by zeolites? Zeolites means what? Zeolites is nothing but a large group of minerals. Okay, a large group of minerals consisting of hydrated aluminosilicates of sodium or potassium or calcium, like that. Okay, you know the meaning of zeolites. Next one is critical missile concentration. Our next concept is critical missile concentration. Next concept is critical missile concentration. What is mean by missile? Missile is nothing but, okay, missile andre ಏನು? Okay, missile is nothing but it is an electrically charged particle. Okay, missile is nothing but an electrically charged particle, okay, built up from polymeric molecules. Okay, built up from polymeric molecules or ions. Okay, occurs in certain colloidal electrolytic solutions like soaps and detergents. Where missile occurs, the certain colloidal electrolytic solutions like soaps and detergents. Okay, this is about what missile. What is mean by critical missile concentration? The particular concentration, okay, the particular concentration above which formation of missile takes place is called missile concentration. Okay, it means that is critical missile concentration. The particular concentration, okay, the exact that concentration, the above which the formation of missile takes place in critical missile is called as critical missile concentration. Example for this one is means example CMS means critical missile concentration for soap in water. For soap in water is, okay, 10 to the power of minus m to 10 to the power of minus 3 m. Okay, 10 to the power of minus 4 to 10 to the power of minus 3 m. Okay, next one is Kraft temperature. What is mean by Kraft temperature? Kraft temperature is nothing but, okay, the temperature above which the formation of missile takes place is called Kraft temperature. Okay, the temperature above which the formation of missile takes place is called as Kraft temperature. Okay, the temperature above which the temperature about the formation of missile. You already know the meaning of missile. Missile takes place is called craft temperature. In bracket Tk. Okay, and the next thing is mechanism of missile formation. Okay, mechanism of missile formation. Next concept is mechanism of missile formation. Mechanism of missile. Missile means it is an electrically charged particle. Okay, missile formation. With an example. Okay. The ordinary soap in water at higher concentration is an associated colloid. Okay, while explaining the mechanism of missile formation, I took the example for soap. Okay, soap in water. So ordinary soap in water at higher concentration is an associated colloid. What is mean by associated colloid? Associated colloid is nothing but the substances which on dilution in a medium. Okay, the substances which on dilution in a medium behave as normal electrolyte at low concentration but behave as a colloidal particles at higher concentration. So because this is due to the formation of aggregated particles. Okay, example for this one is soap in water. Okay, associated colloid. Okay, so the ordinary soap in water at higher concentration is an associated colloid. Example for associated colloid. You also know the meaning of associated colloid. Soap consists of compounds such as sodium stearate. Okay, soap consists of the compounds such as sodium stearate. The formula of sodium stearate is C17H35COONA. Okay, it is the formula for sodium stearate. The stearate ion has long hydrocarbon chain. You already know the hydrocarbon means which contains hydrogen and carbon. Okay, so the stearate ion has long hydrocarbon chain. Okay, so soap consists of what? Sodium stearate. Sodium stearate formula is C17H30. Okay, C17H35COONA. It is a long hydrocarbon chain. Okay, it consists of hydrophobic tail. Okay, hydrophobic tail and hydrophilic head. This is tail part, this is head part. This is hydrophobic because it is a non-polar in nature. Non-polar, you all know the non-polar and polar compounds. It is hydrophilic head because it is polar in nature. Because of this reason it is head. And this one is, it is tail because it is non-polar, it is a polar. Then what happens? This is the carboxylate group. It is acts as a polar molecule. So it is the hydrophilic head and this is the hydrophobic head. Okay, this is the long hydrocarbon chain of sodium stearate. Sodium stearate formula is C17H35. Okay, C17H35 COONA. This is the formula for sodium stearate. The soap consisting of this molecule sodium stearate. Okay, this carbon, if all together count this one is you will get C17H35 and COONA. Okay, Na I didn't mention here, I have to mention COONA. Okay, then what happens in this is the hydrophobic tail and this is the hydrophilic head. Okay, then next we come to stearate ions. Okay, means this is the CO minus carboxylate ion. It is the hydrophilic head and it's a hydrophobic tail. Then what happens? These stearate ions, okay, these stearate ions associated into micelles. You already know the meaning of micelles. Okay, it is electrically charged molecules. The stearate ions associated into micelles in which the hydrocarbon end point means the hydrocarbon end point means this one. The hydrocarbon end point inwards towards the center. Inwards towards means this sides. The hydrocarbon end, this is the hydrocarbon end. Okay, this is the end. Then what happens, this inward towards the center of the sphere. This is sphere. Okay, this is the one sphere. Then what happens, the hydrocarbon end point is inward towards the center. This is the center. Okay, this is the center. Then what happens, the center of the sphere, and the ionic carboxylate ions, this is the ionic carboxylate groups are on the surface of the sphere. Okay, it is on sphere. This is sphere. Then what happens, this is the sphere. The end point of the hydrocarbon, okay, chain, then pull inwards. Okay, end point of the hydrocarbon chain pull inwards towards the center. This is the center. This is the sphere. Okay, and ionic carboxylate ions, CO minus carboxylate ions are groups on the surface. This is the surface. Then what happens, the falling outwards. These are the falling outside the space. These are the falling outside the space. Okay, the aggregate thus formed is known as ionic micelle. This is called as ionic micelle. This is called as ionic micelle. Ionic micelle. In this case, what happens, the hydrocarbon end, okay, pull inwards toward the center. This is center. This is the sphere, and carboxylate ions pull outwards means, okay, then falling outwards. These two forms aggregate. This forms on aggregate. This forms aggregate. That is known as ionic micelle. This is about the mechanism of micelle formation with example. Okay, see once again. Then in this case, what happens? The ordinary soap in water, okay, at higher concentration is associated colloid. Okay, you already know the associated colloid meaning. So then what happens, soap consists of compounds such as sodium stearate. Because of this one, soap consists of sodium stearate. The formula of sodium stearate is C17H35COONA. The stearate ion has long hydrocarbon chain. So it having long hydrocarbon chain which is hydrophobic in nature. You already know the meaning of hydrophobic and hydrophilic also. Water loving and water hating. Okay, hydrophobic tail. Then what happens, the hydrophobic tail, okay, and this one is hydrophilic head. Why it is hydrophobic means it is non-polar in nature. This is polar in nature. Okay, this is about the mechanism. Then what happens, the stearate ions associated into micelles. The stearate ions associated into micelles in which the hydrocarbon end, this is the end, hydrocarbon end point inward towards the center. Okay, sorry, this hydrocarbon end inward towards the center. This inward, okay, inward towards the center of the sphere, and ionic carboxylate groups. This is the ionic carboxylate groups are on the surface of the sphere. Falling outwards. Okay, this falling outwards. This is falling outwards, and this one is inward. This pulling inward. Okay, and because of this reason, one aggregation, they combine each other and they forms aggregates. So because of this reason, this is called as ionic micelle. This is ionic micelle. This is about mechanism of what? This is the mechanism of micelle formation. How the micelle formed? Because of the pulling of hydrophobic tail and